There is a Mangalacharan which one of the participants of the conference is going to sing. This is Miss Ramakalyani.
Nityam Jadhyatamoharam Sumanasam Ullasanam Saprabham Nityam Jadhyatamoharam Sumanasam Ullasanam Saprabham Chaklesham Samayavabodhana Vidho Prodbodhita Jyotisham Chaklesham Samayavabodhana Vidho Prodbodhita Jyotisham Sevyam Mandala Madhyagam Sukritibhiryantram Sputam Bachmyaham Sevyam Mandala Madhyagam Sukritibhiryantram Sputam Bachmyaham Natvaitat gunameva deva mamalam Shri Bhaskaram Bhaskaraha Natvaitat gunameva deva mamalam Shri Bhaskaram Bhaskaraha Shri Bhaskaram Bhaskaraha.
In his most comprehensive and critical history of Bharatiya Jyotisha, the great savant Shankara Balakrishna Dikshit remarks that Bhaskaracharya used his exceptional talents in formulating rationales, upapattis. You have just heard from Dr. Srinivas about the vasanas, for the mathematical and astronomical procedures, but not in advancing the techniques of observational astronomy. Indeed, even in Bhaskaracharya's treatment of the conventional astronomical instruments, one misses the magisterial assurance with which he deals with other topics and notices instead some ambivalence between what is practical and what is speculative. He devotes an exclusive chapter to the description of several astronomical instruments in his Siddhantasiromani, yet he dismisses them in favor of a straight piece of stick, as we shall see later on. Elsewhere, he derides the dimensions prescribed in the earlier text for the water clock as illogical, yuktishunya, and impractical durghata, but at the same time, he does not hesitate to dwell on different types of perpetual motion machines, although he himself was doubtful about their utility in astronomy. I suspect that Bhaskara discussed instruments in his Siddhanta merely because Brahmagupta did so in his Brahmasputa Siddhanta. So we retrace 5 centuries backwards and begin the narration with Brahmagupta. In the 22nd chapter of the Brahmasputa Siddhanta, called appropriately the Yantradhyaya, Brahmagupta offers the first systematic and comprehensive account of astronomical instruments, which he calls Kala Yantra. The astronomical instruments described by him are 9 namely Dhanush, Turyagola, Chakra, Yashti, Shanku, Ghatika, Kapala, Kartari, and Pita. In addition, he also talks about certain accessories for observation. An accessory is some kind of tool for leveling to get horizontality and some kind of means to get verticality in observations, and so on and so forth. And he also discussed some varieties of automata and some perpetual motion machines. But the armillary sphere is not included in these instruments. It is described separately in an exclusive chapter called Gola Bandhatikara because it is an essential part of Gola. Gola, or spherics, as you know, deal with a host of imaginary circles. Just now a mention has been made about these upayas which we resort to. and a host of imaginary circles in the heavens, such as the celestial equator, the ecliptic, and so on, and teaches methods to determine the linear and angular distances between them. By arranging these imaginary circles as physical entities in the armillary sphere, the student can grasp clearly the purpose and function of these imaginary circles. Therefore, Gola Bandha, putting together of different rings to constitute the armillary sphere, is a primary task in understanding Gola. Almost all the subsequent astronomers like Lalla in the 8th century, Shripati in the 11th have followed Brahmagupta's treatment of instruments. Following these predecessors, Bhaskaracharya also devotes in the Goladhyaya of his Siddhantasiromani an exclusive chapter entitled Gola Bandhatikara to the armillary sphere, and a subsequent chapter called Yantradhyaya to 10 different types of measuring instruments and 3 varieties of perpetual motion machines. In addition, he discusses Nalika Yantra in the Triprashnadhikara of the Graha Ganita. Bhaskara discards some instruments discussed by his predecessors and adds some of his own. Those discarded are Kapala, Kartari, Pita of Brahmagupta, and Shakata and Shalaka of Lalla. Those introduced newly by Bhaskara are Nadi Valaya, Palaka, and the Yantra. Lancelot Wilkinson, an officer of the East India Company, was a great admirer of Bhaskaracharya, and he did great in popularizing Bhaskaracharya's writings and in publishing. And he also translated Goladhyaya, which his protege, Bapudeva Shastri, improved and revised. So Wilkinson and Bapudeva Shastri prepared a good translation of the Goladhyaya, including the Yantradhyaya, with useful notes and diagrams. The late Professor R N Rai of Delhi described the construction and use of these instruments in a special volume of the IJHS, and our colleague Yukio Ohashi of Tokyo discussed the same very thoroughly in his doctoral thesis. Therefore, I shall not go into the construction and use of these instruments in detail. My focus will be rather on Bhaskara's attitude towards observational astronomy in general and towards certain instruments in particular, an attitude which baffles me and also which baffled, as I said, as I shall show, Nrsimha Dayavajna. I shall begin with the armillary sphere, which was also discussed by Greek astronomers. Okay. Including Ptolemy, who describes its construction in his Almagest. His armillary sphere consists of a fixed celestial equator and a fixed meridian, a movable ecliptic, and a solstitial colure which can be rotated around the poles of the equator. 2 latitude circles, one inside and the other outside, can be rotated around the poles of the ecliptic. Armillary spheres made according to Ptolemy's model can be seen in nearly every museum in Europe. The Arab astronomers followed the Ptolemaic model, but no single specimen of Arabic armillary sphere, Dhatul Halak, seems to have survived. While Ptolemy's armillary sphere is designed to represent the ecliptic coordinates, the one envisaged in the Siddhantas is made to represent equatorial coordinates. Moreover, it's a much more elaborate affair compared to the Ptolemy's model. The Gola Yantra discussed by Brahmagupta contains as many as 51 movable circles or rings, besides several fixed rings. Brahmagupta does not actually describe the construction of the Gola Yantra. He speaks more about the function of the different rings. The first detailed description of the Gola Yantra is available in Lala's Sishati Vriddhita Tantra, who arranges the various rings in 3 groups. Each group or assemblage of rings constitutes a separate sphere, and these spheres are arranged at 3 slightly different levels on the axis. Lala calls them Khagola, Bhagola, and Grahagola, respectively. Bhaskara made some changes to Lala's design by introducing a Druggola in addition to Bhagola and Khagola. The Bhagola is the sphere of fixed stars. Instead of having a separate bhagola for each planet, only one bhagola is used for all the planets. It consists of the ecliptic, equinoctial, diurnal circles, and so on, which are movable. It is fixed to the polar axis so that it may move freely by moving the axis. Beyond this sphere is fixed the Khagola, or the celestial sphere. It consists of the prime vertical, meridian, horizon, and so on, which remain fixed in a given latitude. Beyond these two is the Dirgola, in which circles forming both the spheres, Khagola and Bhagola, are mixed together. Since the time of Brahmagupta, if not earlier, teachers of astronomy must have taught their pupils how to prepare a Golayantara with strips of bamboo. Indeed, Bhaskara900, in his commentary on the Aryabhatiya, talks about the practice of people making armillary spheres. None of these have naturally survived. However, there are extant a few metal specimens. In 1830s, Launcelot Wilkinson, do we have the right one? Yes. Saw a Golayantra and several other instruments set up on the top of the fort at Kota in Rajasthan. Wilkinson thought that these were set up at the time of Rao Umayyad Singh, who ruled Kota from 1771 to 1819. At present, this Golayantra and other instruments are placed in the Palace Museum of Kota. My good friend Virendranath Sharma has studied this Golayantra and wrote a paper in IJHS. He reports that there are 3 spheres of rings with diameters ranging 120, 111, and 99.5 centimeters respectively. In the Linden Museum at Stuttgart in Germany, there is an armillary sphere which contains 2 sets of rings around a wooden axis. It's a bit smaller one. The outer ring measures 57 centimeters, the inner ring 50, and the wooden axis 80 centimeters. It is said to be from the palace of the Maharaja of Gwalior. Another Golayantra is with the Royal National Museum of Edinburgh. Those of you who have come to the Edinburgh conference of World Sanskrit Conference and joined our section on scientific texts, they may have joined me with an excursion to the museum and have seen this. I think Professor Ram Subramaniam has seen this one. Its inner diameter measures 85 centimeters. The sphere is pivoted to the poles of the ecliptic. There are rings to represent the ecliptic, equator, tropics, and meridians. 12 great circles intersect the ecliptic at right angles, passing through the zodiacal divisions. 20 named star pointers are attached to the rings. Positions of several more stars are marked on the rings. Its provenance is not known. You can see here 2 stars, Phalguni and Uttara Phalguni. A former student of mine has sent me this photo of a Golayantra, which is now at Maharaja Sanskrit College at Mysore, which was prepared, as it states, according to Bhaskara's prescription. Now we go to Ghatika Yantra, which Bhaskara talks about. In his monumental Science and Civilization in China, Joseph Needham classifies water clocks into 3 distinct types: inflow types, outflow types, and the sinking bowl type. In India, the 2nd and 3rd type were used, not simultaneously, but one after other. The outflow type was mentioned for the first time in the Vedanga Jyotisha. In the subsequent centuries, the Ardhashastra and other texts refer to it. This water clock consisted of a hollow cylinder, nala nada, with a small portion at the perforation at the bottom, through which was discharged a certain amount of water in the course of 1/60th part of a day and night, that is 24 minutes. This was the standard unit of time in India and was called at first Nadika or Nadi, based on Nada, a cylinder. Sometime about the 5th century AD, this type of water clock was replaced by another variety known as the sinking bowl type, which was called Ghatika Yantra or Ghati Yantra. You have seen it yesterday already in connection with Leelavati's legend and unfortunate accident of missing her marriage. It was described for the first time by Aryabhata in his Aryabhata Siddhanta in the early 6th century. Thereafter, almost all Siddhanta texts refer to it. In this device, a hemispherical bowl made of copper or coconut shell with a small perforation at the bottom is placed on the surface of water in a larger basin. Water enters the bowl from below through the perforation, fills it, and makes it sink. The weight of the bowl and the size of the perforation are so adjusted that the bowl sinks again in 24 minutes. Thus, the unit of time measured remained the same as before with the old instrument, but this was given a new name, Ghati or Ghatika, because there is a Ghata there, in accordance with the name of the instrument. But later people used both Nadi and Ghati, Natika and Ghatika without any discrimination. From the 7th century onwards, institutions of timekeeping are attested at royal palaces, temples, monasteries, where time was measured constantly with this water clock, and the passage of each ghati was broadcast by means of drums and conch shells or by gongs. The institution was so popular that Muslim rulers of Firoz Shah Tughlaq in the 14th century, Babur in the early 16th, and Akbar in the late 16th also adopted it. Moreover, in Akbar's atelier, the sinking bowl and water basin were depicted in 2 miniature paintings, which are the only pictorial records of this. Here, shows the birth of Akbar, and there is a water clock, and the astronomers are telling his father, Humayun, about the birth, and also there is a horoscope which they have prepared and put in front of him. Then there is another one, which shows the birth of Jahangir, and here you see 4 astronomers seated and beautiful water clock in front of them. I tried to identify these people and argued that the man who is drawing a horoscope here with white turban and red shawl over him is Krishna Daivajna, who is at the court of Akbar and also who wrote a horoscope of Khan Khana Abul Rahim. Okay. This practice has lasted up to the end of the 19th century. Even now it is used for ritual purposes. In Mathura, on the day of Krishna Janmashtami, the exact midnight hour of Krishna is determined by means of the Ghati Yantra. In Jhalawar, in Rajasthan, in the Digambara Jaina temple dedicated to Shantinatha, the 16th Tirthankara, a water clock is employed to regulate all the daily rituals. It was shown recently in a BBC documentary with which Dr. Kim Plofka was associated partially. It is reported that in a place called Sevan in Sindh in Pakistan, the water clock is used to regulate the time of the daily rituals in the mausoleum of Lal Shahbaz Qalandar. So in all the major religions of India use the water clock still for ritual purposes. These watches are not good enough for them. Besides regulating regular timekeeping, the sinking bowl was used for measuring the duration of the supply of irrigation water to individual fields. That's the one which was from Tamil Nadu. And then from India, the device spread to other countries in South and Southeast Asia. Interestingly enough, in Thailand and Indonesia, it was also used for regulating length of cockfights. As you can see from this drawing from Thailand, there is a water clock over there, and here the cocks are fighting. Considering the universal popularity of this water clock, there ought to be hundreds of specimens extant in India. But in India, brass or copper objects which are no longer in use are immediately recycled. Consequently, not many have survived. The largest collection of 7 pieces is in the Pitt Rivers Museum of Ethnology at Oxford. Of the traditional instruments, the water clock is the only one for which the astronomers strove to prescribe exact measurements, not only for the bowl, but also for the orifice at the bottom of the bowl. Thus, in his Siddhantasiromani Tantra, Lalla lays down that the bowl of the water clock should be made out of 10 palas of copper. It should have a diameter of 12 angulas at the top and 6 angulas in height. The hole should be such that a needle made out of 3.5 mashas of gold, which is stretched to a length of 4 angulas, should pass through it. This is a very ancient system of micro measurement, which also Kautilya uses. Now, our Bhaskaracharya dismisses these specifications as impractical. According to him, a bowl of any size with any arbitrary hole can serve as the water clock. It need not even have a duration of 1 ghatika. A bowl of any duration will do for measuring time. Thus he declares, a copper bowl formed like a hemisphere having a small hole at the bottom, the duration of the day and night divided by the number of immersions of this bowl gives the measure of the water clock. This statement is elaborated in the Vasana Bhashya as follows. Here, we ignore the definition of water clock given by certain scholars as Dashabhi Shulbai Shulbasya Palayer, because it is illogical, yukti shunya, and difficult to implement durgata. The strong words he is using are towards Vidya Tantra of Lalla. He's attacking Lalla directly by quoting him. In Bhaskara's view, such specifications for the size of the bowl of the end for Rishna are impractical. On the other hand, Bhaskara goes to the other extreme by stating that a bowl with any duration of immersion will do. So at one time, during a visit to my village where copper coconut shells are easily available, I tried to make a hole into it and then put it in a water basin. The bowl sank in 34 minutes. That means it measured 1.76 ghatikas. I can't use that. Is that easily for measuring hours or measuring ghatikas? It's useless. It becomes complicated. If you want to measure something, say, in half an hour, how do you measure with this? So, and by not insisting that the bowl should sink in 1 ghatika, as his predecessors said, Bhaskara also underestimates the Indian artisan's ability to fabricate bowls of exactly 1 ghatika duration. If you look at the different sizes and shapes of the extant bowls, the Indian artisans did not follow the measurements given by the astronomers. Nevertheless, they were able to make, by empirical methods, bowls that sank in 1 ghatika. So we saw in the case of Ghatika Yantra, Bhaskara is dismissive about exact specifications. Now we take the Shanku. Like the water clock, the instrument called Shanku was also in use for a long time. I won't go into the history of this Shanku, which you know very well, and it's an important unit. It's an important tool in the Triprashnati Kara. What does Bhaskara say for this? He says that a gnomon, Shanku, should be made out of ivory, and it should be produced on a lathe so that the circumference at the top and bottom is the same. This is surprising. We have just seen that in the case of water clock, he asserts that exact dimensions of the bowl and hole are unnecessary, but here he specifies that it should be made out of ivory only. Surely wood or bamboo would have done the same business. Moreover, a gnomon made of ivory could not be very long. If you want to make an ivory stick of very length, you have to spend a lot of money and so on and so forth, resources. I shall skip other variants of the gnomon like Yashti Yantra, Di Yantra, and Nalaka Yantra. And I go to the 3 Chapa, Chakra, Chapa, and Turiya. The Chakra circle, Dhanush semicircle, Turiya or quarter circle are closely related in shape and function. Chakra is a circular wooden plate which is circumference graduated into 300 degrees. Dhanush is the half and Turya Gola is its quarter. Brahmagupta discussed these three and he prefers semi-circular variety. Bhaskara likes the circular variety, and he says that the circle should be divided into 360 degrees, the rim, and vertical and horizontal diameters should be drawn on it, and an axis should be measured. And with this, sun's altitude, Unnatamsha, and the zenith distance are measured. And having described the construction of the use of the Chakrayantra in detail, Bhaskara laconically that Chapa and Turya are half and a quarter respectively. Here I show you two examples of a Chapa Yantra with Gurumukhi script, another Chapa Yantra, and another Turiya Yantra. We go to the Nadi Valaya. The Nadi Valaya is a variation of the Chakra Yantra, but Bhaskara says it should be placed in the plane of the celestial equator without stating exactly how it should be placed. So Nadi Valaya is literally it means circle of nadis or circle of gatikas. The rim is divided into 60 gatikas, so you can measure time and other parameters. When Savai Jai Singh set up observatories with new types of masonry instruments, he modified Bhaskara's design and set up a Nadi Valaya in stone and plaster. Here, the instrument has two parallel sides, one facing the North Pole, another facing the South Pole. Now, the Palaka Yantra is Bhaskara's own invention. He declares that he has designed it to ascertain the apparent time, Sputakala, from the Drung Mandala, the vertical circle passing through zenith and the planet. Since this instrument is his own invention, he begins with its description with a Mangalacharana in the middle of the chapter, which you have just heard recited. The verse contains two levels of meaning. In one, all the attributes refer to the sun god, and another to the Palaka Yantra. Unlike the other verses of this nature composed by Bhaskara, here the Slesha double meaning is somewhat belabored. Poetically, it's not very impressive. Unfortunately, this instrument is not very impressive either. The Palaka Yantra consists of a rectangular board measuring 90 times 180 units with 90 equidistant horizontal parallels are drawn. At the middle of the 30th parallel is inserted a pin to which an index is pivoted. With this pin as the center, a circle is drawn with a radius of 30 units and the circle is graduated in 360 degrees. This instrument is used for measuring the sun's altitude and then for determining the time graphically. The only interesting point is I was looking for specimens of Palaka Yantra, and I came across a few. I'll show these to you quickly. In the archives of the Museum of the History of Science at Oxford, I saw the photos of a Sanskrit astrolabe, its front and back. On the back, well, this is the front of the astrolabe, and then on the back, over the top, it's a bit difficult to read, I have put this there, and it says, Chakra Turiya Palaka Yantranam Ekatra Samavesha. The circle, the rim with 300 degrees is the Chakra Yantra according to Bhaskara, and here on the right hand, on the left, upper left quadrant, usually they have a sine quadrant, and then here these parallel circles, these constitute parallel lines, these constitute the Palaka Yantra of Bhaskara. It's rare that on astrolabe anybody puts Palaka Yantra there. Therefore this is a unique instrument. We don't know where it is. All that I know is that there is a photograph in the archives. The second specimen is with the dealer of scientific instrument in the United States. It is still with him if it's not sold out. It's a casket, and can be used as a diptych, which is when the lid is lifted up. Yeah, now here there is a string there which going from below to the above, and the string casts its shadow. It's a very common instrument in Europe. This particular specimen was made very crudely by Joshi Ramachandra in 1885 at Kuchaman in Rajasthan. On the upper and lower sides, Joshi Ramachandra incorporated two traditional Indian instruments. The upper layers, on one side is painted the Dhruva Brahmayantra, which was invented by Padmanabha in about 1423, and on the other side he drew Palakayantra of Bhaskara. There, I mean, it's a very faint photograph. Then, now we come to a third specimen. On 5th January 1876, the Maharaja of Benares presented the Prince of Wales with a set of astronomical instruments. Dr. Baedeker, during one of his visits to the British Library, found an account of the travels of the prince, and in which he saw a list of instruments carefully prepared by Babudeva Shastri and sent it over to me. I'm very grateful to Dr. Baedeker for this list. I was much impressed that this list includes a Palakayantra. It is not known what happened to these astronomical instruments. They may have been put in some royal palace and forgotten. I have just published an account of these instruments in the Bulletin of the Scientific Instrument of Society of London, and hope that some British historian of instruments may find out the present location of these instruments in the near future. Now I come to a class of instruments called Swayamvaha Yantras, or perpetual machines, motion machines. Aryabhata and Brahmagupta describe some automatic devices with amusing display of periodic movements, such as the Vadhu Vara Yantra, the bridegroom and bride instrument, where a laddu passes from the bridegroom's mouth to the bride's mouth at the passage of each ghatika, and so on. Here, oh, that's Maharaja, okay. The Maharaja is, yeah, there it is. So there is this cylinder with water, and the water is going slowly down, and there is a weight there filled with mercury, so the weight of float comes down slowly. As it is coming down, a knot is passing from bridegroom's mouth into bride's mouth. In theory, you can regulate it that it can do every hour regularly, but in practice it does not, because the water pressure changes gradually. This was noticed later by Nilakanta in his commentary. Anyway, there are lots of such instruments described in Surya Siddhanta and etc., etc. Bhaskara rejects them as rustic contrivances, gramya, he says. His reason for rejection is that these devices have to be refilled with water afresh every day. He would like instruments that turn absolutely on their own, without the aid of any human agency, nirapeksha, and forever ajasram. Brahmagupta was the first to describe such a perpetual motion machine. It's a bit of light wood. Into its rim are inserted at equal intervals hollow spokes of equal size. Each spoke is half filled with mercury and then sealed. When the axle of this wheel is set up on two supports, the mercury runs up and down the spokes, and the wheel turns perpetually, ajam brahmati. Brahmagupta's idea of perpetuum mobile was taken up enthusiastically by Bhaskara, who discusses three different models. But Bhaskara does not see any connection between the serious pursuit of astronomy and these self-propelling devices. He says that these form part of juggler's equipment, kuhaka vidya, and have no relevance in elucidating the principles of spherics, nedam golashritaya. But why did he take the trouble of discussing them in his own book? even going to the extent of suggesting improvements on Bhaskara's original model and proposing 2 extra models. For our disappointment, the Acharya says that he discussed these devices here only because the previous astronomers have discussed them. Purvoktatvat mayapi uktam. Nevertheless, these instruments, these models deserve close attention because they are relevant for the history of technology or history of ideas regarding technology. So his model number 1 is an improvement on Brahmagupta's design. Brahmagupta Bhaskara suggests the spokes should be slightly curved, all in the same direction as in a Nandyavarta. Nandyavarta flower is Taberna montana coronaria. Mrs. Pedeker tells me that here it's called Sadapuli. Outside, if you step out, you have hedges made of this Sadapuli with rather pale leaves. So that's his model. Well, model number 2, Bhaskara proposes a new variation in which a channel is cut in the rim of the wheel and filled half with water and half with mercury. The water trying to flow downwards pushes the mercury and vice versa, and this internal tension resulting in the rotation of the wheel itself. In the third model, the rim of a large wheel to the rim of a large wheel are tied a series of pots at regular intervals, as they do in water wheels used in irrigation. These pots are successively filled with water from a reservoir, kunda, by means of a siphon. The word he uses is kukkuta nadi yantra. The pots at the top, when filled with water, become heavy and move downwards, causing the wheel to turn. The water discharged from the pots below is made to flow into the reservoir by a channel below. Thus, there will be no need to refill the reservoir again. As we saw earlier in connection with the water clock, Bhaskara is usually dismissive about the mechanical details. But now he describes the siphon in great detail with an analogy from the daily life. Since such descriptions of tools and devices are very rare in Sanskrit, I shall cite the full passage from the Vasana Pasya and seek your indulgence. Take a tube made of copper or any other metal, bend it like the elephant's goad, ankusha, fill it completely with water, hold one end in the water in a vessel and other end outside. When both ends of the tube are opened at the same time, all the water in the vessel flows out through the tube. We played with such things as children. And then Bhaskara goes on to say, this happens in this way. Take a lotus stalk, remove the lotus flower from it. The holes of the stalk are filled with water. Put one end of the stalk in a vessel filled with water and release the other end outside the vessel. All the water in the vessel flows out through the stalk. This device is well known to artisans, shilpins, and to the haramekalins. I don't know what our haramekalins are, under the name Kukkuta Nadi Yantra. Both these words, haramekali and Kukkuta Nadi Yantra, don't occur anywhere I searched long. With this device, many amusing tricks can be performed. Okay. Now tie up a series of pots along the rim of a wheel, set the axle of the wheel on 2 supports, as in the case of Noriya Jalayantra, in such a manner that the water discharged from the curved tube falls into the pots. Pulled downwards by the pots filled with water, the wheel turns. Now when it is so arranged that the water discharged from the pots is transported to the reservoir by means of a channel below, there will be no necessity to fill the reservoir again and again. Okay. Now, there was a great, good. Modern science ridicules the attempts of such perpetua mobile as attempts of mere flights of fantasy. Lynn White argued that fantasies are also important to the history of ideas, and he says that these ideas of perpetual motion machines gave rise to industrial mechanics of producing energy for the benefit of mankind, and he traces the idea to Bhaskara of 12th century. Now, he was attacked from the two sides. Needham said such things existed in China in the 11th century. And from the Islamic side, they said, we have also manuscripts of this kind in Islamic technology, they said. So they discussed this at length, but the amusing point is they did all this discussion on the basis of just two translations of English translations of Sanskrit text, namely Surya Siddhanta and this Wilkinson's translation of Gola Adhyaya, but they did not read Brahmagupta's Brahmasputta Siddhanta, where the idea of perpetual motion arises. Anyway, that's one of the amusing things, but now come to the conclusion. Bhaskara is actually at the turning point of history of astronomical instruments in India. Soon these instruments described from Brahmagupta to Bhaskara became obsolete with the introduction of astrolabe, which incorporates also the sign quadrant. Commenting on Bhaskara's Chakrayanta, which consisted of a circular plate with a graduated rim, in his Vasana Vartika of 1621, Nrisimha Daivagnya remarks that the same Chakrayantra is called astrolabe when it is equipped with latitude plates and rete. Idameva Chakrayantram Achapatra Bhapatra Yutam Yantra Raja Yutam Iti Ahuhu. Now, at this point, Mahendra Suri makes a huge digression and quotes a large number of texts. And so a study of this portion itself would make an important paper. I'll skip quickly, and so that would be Chakrayantra, and into this you put a Akshayantra, and so this is made for the latitude of Banaras, and then you put a Bhapatra where it is for different things. Now, our Nrisimha Daivagnya wonders why Bhaskaracharya, the great Bhaskaracharya, did not discuss this thing. And then he explains, you see in a Yantra Raja, this Achapatra has to vary from place to place according to the latitude. And this Bhapatra has to vary according to the longitude of the stars, and the stars' longitudes vary due to precision. Therefore, an astrolabe becomes obsolete in 67 years. Therefore, Bhaskaracharya did not discuss this, otherwise he would have discussed this. Likewise, he discusses all the advantages of using a quadrant and says, why did Bhaskaracharya did not talk about it? Grantha Vistara Bhayat. So he did not discuss. But the actual fact is these two instruments came much later. They became well known only at the later half of the 13th century under Firoz Shah Tughlaq, and once they came, the instruments discussed from Brahmagupta to Bhaskara onwards became obsolete, and there are no actual specimens extant anywhere. As I said, there are 3 possibilities of Palakayantra existing somewhere. Hopefully I'll find them someday before I finish my catalog. This completes my presentation. I thank you most cordially for your patience and offer you a bouquet of Samudra Pool, which I discovered on the Marine Drive during my last visit to Thane. Thank you very much.
Yes, questions.
On the last Sorry?
Last point, that when Firoz Shah Tughlaq, this thing came, it became obsolete. So
No,
what
no.
came at the time?
At the time of Firoz Shah Tughlaq, the astrolabe was introduced. Firoz Shah Tughlaq sponsored production of astrolabes in India, and also at his time, a Sanskrit manual was on the astrolabe by Mahendra Suri at his court, and subsequently they were made at least a dozen or more Sanskrit books are written on the astrolabe, and they are extant at least 120 Sanskrit astrolabes in various museums.
Sir, which work of the Nilakantha has the reference of this Vadhuvara Yantra?
No, he did not talk about Vadhuvara Yantra. You see, in Aryabhatiya itself, there is a reference to this measuring time by the rotation of a circle and by using such a float. And somewhere in talking about Aryabhatiya Bhasha itself, there he says that if the cylinder has the same shape, its regular shape, it has the same diameter above and below, then water pressure will be changing and the water discharges at an irregular rate, so therefore the time periods will not be uniform. So he said, therefore, the upper diameter and lower diameter should be different. He did not say how different, but it was different in the so-called Egyptian water clocks, which are shaped like this.
Thank you.
Yeah.
Thank you for that. That is fascinating, and I think we're all eagerly looking forward to the publication of the catalog. I had one suggestion about the point you raised concerning the manufacture of the gnomon and the specification that it should be from ivory rather than wood or bamboo. The only reason I can think of for that stipulation might be that, especially in humid climates, wood or bamboo would very easily warp beyond at least to a point at which they wouldn't be very useful for a gnomon. Ivory, though it is, difficult to obtain and expensive, at least has the advantage that it doesn't have that, cellulose warping effect.
A paragraph which I skipped was, in fact, I wrote a paper early on Brahmagupta's Astronomical Instruments, and there I argued, if you look at the instruments prescribed by them, they're all simple, except the water clock. They're all made very simple. They could be easily produced everywhere. So suddenly Bhaskara telling you need ivory, whereas for other things he doesn't say anything, is a bit surprising. Yes, I mean, you can argue the ivory would be good, and maybe he has enough money to buy an ivory. No.
Clemency suggested maybe he's being funded by the ivory charges.
Yes.
I was curious to know about this Dhiyantra that you mentioned.
Yeah.
And what is the kind of instrument and why is it called Dhiyantra?
It's the same Yashti Yantra. This is the slight difference is you have a gnomon which you fix on the ground, you draw a circle, and then various other, you make diagonals and vertical, and then you make measurements. And the Yashti Yantra is you just hold it above. And then from here you have to put a string or something like that and draw verticals and look on the ground with the circle. The yantra is almost the same, nothing but a Yashti yantra. Why he called it a Di yantra is not very clear. He just suddenly he said, "Oh, you don't need all of this, just a Di yantra would do."
See, regarding this statement of Bhaskara on Lalla's prescription, I have a view that perhaps he tries to dismiss that these dimensions alone may not be sufficient because it has to do with the shape or the curvature of the vessel. Is he trying to completely dismiss this, or is it something else?
No, he completely dismissed this. There are some other problems here. I didn't go it. There is, in this, I don't have the text. There is the chidre aprudhu chidre. Before that, some other word comes. Therefore, this A is suppressed. All right? And so it has to be an avagraha. So in printed version, in written versions, they omit the avagraha, pruduchidre. Now, pruduchidra would be, if it sinks in 10 minutes, you will go on refilling and doing this all your life. I mean, you need lots of people. So it's not a useful thing. And now, so is it pruduchidra or pruduchidra? Munishwara says it should be aprutachid, it should be pruduchidra. Here he says, there is no occasion for putting an avagraha here, he says, because a pruduchidra is important so that any dirt which comes will not go down and so on. So, but that is nonsense, because they say use clear water, they don't say any dirty water. Generally they say to use clear water. So that is what the textual problems are also there. So apparently, I mean, I'm surprised that Munishwara said the chidra should be very prudu, large one. I mean, didn't he see any water clocks around him in Banaras? I mean, there is also a question is that astronomers and all great Brahmins don't pay much attention to artisanal things. What the Shilpi does, very menial work, we don't do it.
Let me have a question about observatory. In Jaishan's Jantar Mantar, that is an observatory, I think. But is there some text which describe about the place where they observed stars with instrument? Observatory.
I talked yesterday about the legend of Bhaskara Leelavati. There are other legends also. One of these, when you look at any internet edition, you would find a sentence, though born in Bidar, he became the director of the observatory at Ujjain. As if it's very difficult to do that. I mean, they think that Bidar and Ujjain were very far and it's difficult to travel all this time, but you have the examples of, we have heard of how this Bhaskaracharya's family moved. We have heard of Bilhana traveling from Kashmir to, he went on to Karnataka all the way, and then we always discuss about various astronomers from Maharashtra to whom Dr. Balachandra Rao referred. They're all from Maharashtra and traveled to Kashi and settled there. Some of them became court astronomers of the Mughals at Agra. So they were going from, I mean, those chaps whom I showed, two of them, the Hindu astronomers, they lived in Kashi, but they were at the court of Akbarat. So they were traveling all the time. So though born in, that's one legend, one absurdity. And then there is the question that in Ujjain there was an observatory. Ujjain, they did great observations. There's nothing of that kind occurs in Sanskrit. An observatory is, if you say, a place where there are instruments, where a group of people made regular observations. No such thing existed in India. I mean, people, any Brahmin, he made his observations from his house or in front, he walked a little bit outside, they would have a clear horizon. Today we don't have a clear horizon. You have to go up very high onto the mountain, but they were small villages and there was always a river, you go up to there and you have a clear horizon and you observed it. That problem also occurs now when you use a ghatika yantra, you begin it at the morning, at the sunrise. Sunrise means when half the sun is above the horizon. How do you determine that? So when I hear that in Mathura, they do measure Krishna's birth at midnight with this machine, I wanted to go and find out, but it has been always a bit difficult. You can't go unless you are a VIP to see the observation. Which means they should begin at sunset. They should observe the sunset precisely when the sun is half set, and then put the ghatika yantra and go on measuring, and then measure when the midnight hours strikes. And also they have to make a variation with the hours of sunset for the Mathura latitude. And so likewise we heard that this in Jalawar they use this instrument, and this group which you were connected, you were with the documentary in Jaipur. Yes. And then they went to Jhalawar. And in Jhalawar. And so you find they just get down at Jhalawar, take a auto rickshaw, stop some people. Where is Jalagati Yantra? They asked people. Nobody knows Jalagati Yantra. They got it from R Sarma's papers. And in fact, I was mentioned as advisor also in that. So they keep asking, and one fellow says, I know where Jalagati Yantra is in English. And so they take him to this temple, and there is a very indistinct, badly focused photo of water clock there. But actual question is, how do they begin? So if you get a chance, please go to Jhalawar and examine that.
Last question. You mentioned Mike. You mentioned Sarma relating the Chandrayaan to the asteroid. Could you say a little more about it?
Yeah, I mean. No, I understood. The Krishna Simha Daivagnya related Chakrayantra to astrolabe. What did he say? I mean, Chakrayantra is actually a circle where the rim is graduated in 360 degrees. And then Krishna Nrsimha Daivagnya says, the same Chakrayantra, when it is to which if a Akshapatra, latitude plate, Bapatra, the star, or the rete is added, it becomes astrolabe. But now, making a circular disk and graduating the rim with 300 degrees is an easy business. But to calibrate a latitude plate for a particular latitude and make stereographic projections on it, for which you need lots of calculations. It's not an easy task. And likewise, to prepare a astrolabe reed is also not an easy job. So it would be like saying the same wheel to this wheel, which you find in the bullock cart, to which if you put a body and a motor, then it becomes a car. So, I mean, it's something like that. He was being very simplistic about it. But the important point of Nrsimha Daivagnya is, I mean, he had great respect for Bhaskaracharya, but he was making a ahistorical statement. Why did Bhaskaracharya did not talk about these instruments? But leaving that aside, that past his discussion about Islamic astronomical instruments in this section, a very large section with large citations, is very important. And there is a book called Yantra Prakara by a Ramachandra Vajpayee. There is only one manuscript available, one full and one partial. And here you have a long citation, therefore you have a third testimonial. Therefore that's very important. Likewise, he also quotes a long passage from this Padmanabha's Dhruva Brahmayantra. And a number of, and then he is the one who discusses in Sanskrit the celestial globe, which is known from the Yavanas he knows. So celestial globe he describes. And then he says, but they have lots of stars, but don't use those stars because they are not familiar for us. For example, a star, something like Cetus, Alpha Ceti or Beta Ceti, Samudra Pachi is called in Sanskrit astrolabes. That's not useful for us because it's an unfamiliar star, and these unfamiliar stars working with unfamiliar stars would lead to some kind of a mangala, he says. Islamic stars, yeah. So, but then leaving that thing aside, it's a very valuable text. Hopefully, if I have the energy and time, I'll write a paper someday on Nrsimha Daivagnya instruments. That separate part worth reading.
Yesterday, Dr. Jamkhedkar
told about the relation of Parmara King Bhoja with Bhaskaracharya's family. And Bhoja in his Yantradhyaya chapter has described so many yantras, and at the end of that chapter he says, I have prepared these yantras first, and this chapter is a document of that. Now those yantras are not available for us, but perhaps Bhaskar might have either seen or must have certainly read this Yantradhyaya. But in that Yantradhyaya, there is no Ghatika Yantra or any astronomical. So I don't know.
No, I mean, I have also read the Yantradhyaya. In fact, Yantradhyaya of Samarangana Sutratara has again a special Mangalacharana, and I quoted that in my paper on perpetual motion machines, which I wrote long ago. But they were, most of them are automata. And that also requires a detailed analysis and sources, this Yantradhyaya. So thank you very much.